What do you say? Here we go. Reason I'm giving out these colored pencils now, the proofs now, the triangles I'm asking you to prove congruent will be overlapping. So you definitely, want to see which two you're working with. Before we dive right into this first proof, we got to take a time out here. All right, let's review, because I know this was a sticking point for some of you on the quiz earlier last week. I only got 5 methods to prove triangles congruent. It's not a choose your own adventure, name your own. Here we go. What do we got? Side, side, side. Side, angle, side. Angle's got to be in the middle. If it's not, don't even sniff it. Angle, angle, side. Angle, side, angle. HL, yeah, don't forget about it. Everyone forgets that because it doesn't have an A or an S in it. So those are our options. You have no other options. That's it. That is it. Those are our options. Also, I just want to review from Friday. A, B, C. Here you go. Watch. What else do you know? What else is true? If I just give you that diagram. Scott, let's go. Angle C and angle A. In a triangle, congruent angles are across from congruent sides. That we can use in proofs now if we need to. Don't forget about it. Let's roll. Let's roll. I got triangle RMS. Everyone see overlapping already here? And RNS. Ooh, all right, wow. TR, TS. All right, before we start writing down statement 2, I do want to make a plan. All right, I gave you 2 pairs of segments equal. Are any of those pairs full sides in my triangles I'm asking you to prove congruent? Okay, let me start. TR and TS. Are those full sides in the triangles I'm asking you to prove congruent? Yes or no? No, they're not. Done. Are TM and TN, the other set, are those full sides in the triangles? No. What am I basically telling you here? I gave you no sides or no angles. You are on the hook for all 3 paired right now. Okay. I did not give you I'm not putting an S in parentheses or an A in parentheses at all. All right, so you're on the hook for the other 3 pair. But you can use them, though. You can use them. Just because they're not full sides doesn't mean I just look away from them. All right. I need sides or angles from somebody. Sides or angles. Dig deep. Dig deep. Don't give up. Look at the 2 triangles you've highlighted, hopefully, or colored in. Do you see any sides or angles that possibly could be congruent? Let's get me there. 9, want to start us off? Anything. Angle. Okay, angle TSR, and what other angle? TRS. Nice. A lot of people don't see that one right away. Maybe some of your classmates don't either. Here you go. These 2 right here. This one and this one. Those are in both triangles. Where does it come from? Here you go. Let's see. Where did it come from? Who's got 12? 12? Luke, what type of triangle is this? You may not have seen it originally, but what type of triangle is TRS? And what's across? What did we learn Friday? What's across from the congruent sides? Which is the one Lisa just gave us. Perfect. Everyone see that? Oh, this is darn right you do. What? Just stop. Just stop. You good? Hypotenuse leg. What are you doing? I don't know. Me neither. Me neither. That's 30 seconds I can't get back in my life right now, Dia. All right? Important. And you just took somebody's oxygen away. There you go. Good. Ready? Everyone see that? I'm joking, by the way. You know that, right? We're all good. We're on the same. I don't want to some kids get offended because they don't understand my joking around and I get in trouble. You know I'm joking, all right?
Yeah.
Okay.
Also joke too.
All right. Well, hey, if I bring it, you can bring it back too. All right, you better just watch yourself because I just come back twice as hard. King of comebacks. Remember that. King of comebacks. All right, so everyone see in all seriousness that this is an isosceles triangle? So here we go. This is what I had you write down a couple times in your notes on Friday. In a triangle, congruent angles are where? Look back if we need to. In a triangle, congruent angles are? What did we write? In a triangle, congruent angles are? Across from, you can use the word opposite too. Across from congruent sides. Start looking for that. That's going to be huge now in your proofs. Oh, it's isosceles, so now I got angles too. All right, so I got a pair of angles done. I still need two more pair of something. Sides or angles, I still need two more pair. What else do you see here? Lisa took the tough one for you, by the way. 24, Romeo, you see anything else here?
TR minus TM equals TS minus TM.
Little subtraction from the givens. Everyone see, if I take TR minus TM, oh, I get a full side, MR. I'll do the same on the other side of the triangle. Good. So TR minus TM equals TS minus TN. Good work. That's subtraction. Yes, things are getting a little tougher in here as far as the proofs go. But you know what's not getting tougher? This next step, that's always the same after we do subtraction, which is, it's always substitution. And what two sides am I going to say are congruent? Now, I want to make sure we're all on the same page. What type, what two? Relax. 11, what two sides? We don't have an 11. Got it, even before you could tell me. 15, what two sides are going to be equal based on substitution now? Good, MR congruent to MS. Perfect. Look at us, huh? We got a pair of sides and a pair of angles done now. I need one more pair of something. All right, one more pair of something. Dig deep here. This is where the highlighting comes into play, I think. This is where it's huge. Do we see another pair of sides or angles that you can see here? Whew, 12. Anything here?
Yeah, it's that RS is congruent to RS.
They both share RS, don't they? Everyone said they both share RS. Perfect. Great job, Luke. RS is congruent to itself. Reflexive. Perfect. That's why I think highlighting helps you, hopefully. You can see you highlighted the same side. And there's a side. So really there's only one method we could use here. Triangle RMS congruent to RNS. What do you got for my method? 18. Method, two triangles are congruent by? Side, angle, side. Yep. This isn't anything new, except for now, come on, see if you're involving an isosceles triangle or not. Because that could get you a pair of angles or a pair of sides. Questions from you guys? All right, I am going to let you work in your group right now in the next one. Another pair of overlapping triangles. Come on now, dig deep. We're not giving up on it. Talk to each other if you're stuck. First thing you want to do, in the givens, do I have any full sides or full angles so I know what I need? Give me something you're confident in. first thing before I call on anybody, did I give you sides or angles you could use in side, angle, side, 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 angle, side, angle? One, right? I did, correct. And that would be AE and ED. I get those are full pairs of sides. AB and CD I can't count. I can use, but I can't count. And put an S next to it. Give me something you're confident in. 19, something you're confident in? All right, BC, congruent to BC. Now, that's something I need in my proof, but I'm not going to count it as a side, am I? That's not a full side in either triangle. So I'm not putting an S next to it, but it is needed. I don't know if you see why it's needed, but it is needed. Good? All right, something else you want me to throw up there? I don't have to go in any particular order. 15, anything else here where you're confident in? There we go. Why did Zach give me the BC? So they could add it to AB and CD to get a full side. Everyone see I'm doing addition to get a full side. AB plus BC is going to be equal to CD plus BC. Addition. And then I'll take the next one. If we're going to do that, we go right to substitution. To get, let's see, AC equal to BD. There's another pair of sides down. Great job. We're working right now. Any other issues now? Okay, next. And even if you didn't find it, I'll help you. Anything else you found? 9. Anything else we found? There you go. Angle, I'll just call it angle D, congruent to angle A. Convenient, I called on you for this one again, Lisa, right? What type of triangle is it? It's isosceles. So that means the angles across from AE, look, the angles across from AE and ED are equal. A and D. In a triangle, congruent angles across from congruent sides. And there's the angle. And then I think there's only one method I won't even ask everybody, side angle side. Okay, side angle side. All right, so that was fun, right? Proving those triangles congruent. I'm going to go backwards now. I'll give you some info. You tell me why the triangle's isosceles now. All right, tell me what makes a triangle isosceles, by the way. It's got to have what?
Two congruent sides.
Two sides equal, or it could have what? Now, based on Friday, it could have two sides, Romeo, or what? Two angles. It doesn't have to have both. You show me two sides, you got an isosceles triangle. You show me two angles, you got an isosceles triangle. I don't need both. So let's see if you can get me angles or sides here. 3 congruent to 4. Those angles don't count because they're not in the triangle. So why is triangle ABC isosceles? So here's your goal. Get me two sides or two angles equal. And this is a review theorem. This is a review one. And yes, I put 1 and 2 in those spots for a reason, for you to look at them. Anybody remember the relationship between 1 and 3 and 2 and 4? What we used to call those back in the day here. Hi, Callum. How are you? I'm doing well too, thanks. Yep, they're linear pairs, right? So what? Keep going. That means they're what? Okay, everyone agree? 1 and 3 are supplementary. 2 and 4 are supplementary. Yep. Some of you maybe don't know where we're going from here, but just hold on. Angle 1 and 3 are supplementary. Angle 2 and 4 are supplementary. Ooh, what's that reason we used to be up here in pink? Linear pairs are supplementary, yeah. All right, well, where are we going with that, right? Where are we going? Well, take a look. 3, and what's 3 supplementary to again? 1. What's 4 supplementary to? Okay, are 3 and 4 supplementary to the same angle? No, but they are supplementary to, what do you know about 3 and 4? Congruent angles. Supplements of congruent angles are congruent. That's how I get 1 and 2 equal. I use that theorem from Unit 2. Supplements of the same angle are congruent. You do not stop. You don't need to tell me this. Is this isosceles now if you know 1 and 2 are equal? All right, I know a lot of people want to say the sides. You can, but it's not needed. This is already isosceles because these 2 angles are congruent. Triangle ABC is isosceles. I'll listen to you guys on this one. I'll listen to you. What would be a good reason here? How do you know? How do you know it's isosceles? Based on the work we just did. Why is this triangle isosceles? Look at the work you just did. I'll take a lot of, there's not really one I'm looking for here, a reason. Zach?
2 angles are congruent.
What's that?
2 angles are congruent.
All right, ready? I'll take that. 2 angles congruent imply isosceles triangle. How about that? If you did the sides, you'd say 2 sides congruent imply isosceles triangle. Right? But you need 2 angles or 2 sides before you say the triangle's isosceles. Ooh, I'd watch it before you turn the page. This last one is hot. Hot.
Yeah, it looks really hot.
All right. I'll take it. Toughest one we'll do here. Right now, toughest one we'll do. I'll let you guys get set up. All right, let's talk. All right, I don't want you trying this out on your own here. Let's talk. First thing, angle already. Angle and side already. How about that? So you need one more pair or something. Okay, let me talk about this given right here. It says triangle CDE is isosceles, which we all know it's got 2 sides congruent. Everyone agree? Okay, but you can, guys, please, you cannot assume it's just the right and the left. 2 out of those 3 sides are congruent. This is why it gave you base CE. If you got to look back in your notes, look back in your notes. What was called the base in an isosceles triangle? That was the what? What was referred to as the base? Romeo?
The side that wasn't congruent.
The non-congruent side. So if CE is the non-congruent side, that automatically tells me for sure the other 2 sides, CD and DE are congruent. You can't assume it's just right and left every time. All right, I got to know what the base is. That's why they gave it to you. So I want to make sure we're clear. I had to include what the base was so you knew what the two congruent sides were. You do not need to put that in your proof at all. That's given, that those two sides are equal. All right, where are we going from here? Because obviously I got 9 angles up there. We need something congruent to each other. I need angles congruent in these two here somehow. I need one more pair. Luke, what's the first pair of angles you see that are congruent for you?
I said angle DCE is congruent to angle DEC.
Would you be offended if I just used the numbers instead? Okay, so 4 and 6. So 4 congruent to 6. That's the theorem I provided you on Friday, which says what? In A, got to start it out this way. In A, triangle congruent. Angles or sides, doesn't matter. Angles are where? Across from congruent sides. Yep. All right, good. 4 and 6 are equal, but again, I need angles inside the two triangles there, like a 2, a 7 in there, right? Via?
Can you also say that angle 4 is equal to angle 2 and angle
You know how I roll. I like one at a time. Okay. Could you put both pair of vertical angles in the same step? Yes, but I'm going to do it one at a time so you can see what's going on. All right. So just pick one pair of vertical angles.
Okay.
Angle 4 congruent to angle 2, and hopefully you'll see why here in a second. And that's because they're what, Via?
Vertical angles are congruent.
Yep. Okay, 4 was equal to 6 because it's in an isosceles triangle. 4 is also equal to 2 because they're vertical. Give me a conclusion based on those two statements. 4 and 6 are equal. 4 and 2 are also equal. Therefore, these two angles also have to be equal. 23. I got 4 and 6, and I got 4 and 2. What else do you have?
6 and 7.
I don't want those yet. All I want, let me be clear here. Out of these two here, 4 and 6 are equal. 4 and 2, so now you know 6 and 2 are equal. Great. And what did you use to get those, Lucy? Good, substitution. So now I know 6 and 2 are equal. Wait a second. Don't I know something else is equal to 6? 6 and 7. And this is why I put it in 2 different steps and put it into 1. You guys can clearly see I have to substitute twice. What type of angles are 6 and 7? Vertical angles are congruent. Now look at steps 4 and 5. Wait a second. 6 was congruent to 2. And now we're saying 6 and 7 are equal. So what two angles now will be equal? 2 and 7. My fear, everyone, is if you put those vertical angles like Via was about to do in the same step, you might only substitute once to say 2 and 7. But how many times are we going to end up substituting? 2 times. 2. So that's why I like everything in one separate steps. Substitution. Now that gives me another pair of angles. So can we say the triangles are congruent now in step 7? What method? Ooh, I always love this one. Is it angle side angle or angle side? Here's your answer. Look at one triangle I'm proving congruent. And here's the angle we had right there. Is that side in between? Absolutely not. So it's going to be angle, side. Question. That was a tougher one. Sorry, this was a tougher one. All right, go. You guys are on your own. Go ahead. I don't want to start any. We'll have all day tomorrow to do the review, cumulative stuff.
Okay.
Colored pencils if you need them.